Hello, this is my Git small project tutorial. It helps you learn more about Git and how to use it on small projects. When we do work with Git for class or for work, we usually start with somebody else's code. Right? We usually do this by cloning a remote repository. Okay, this is where you pick up the code base. Whether you're doing this in class, my class, you'll create a repository at GitHub and then you'll clone it down your machine. Or if you're doing stuff with a company, you'll clone their remote repo onto your machine and start work. Okay, so that's a little different than if you're doing your own project, your own personal project. You're going to create that repo. You don't need to use a remote repository. Commit procedures. When you work for a company or on a project, commit procedures may be constrained. Okay. In my class, they are not. You are allowed to commit as often as you like, whenever you like. Branching, on the other hand, in my classes and in other projects, generally is constrained by the project owner, your boss, or in my classes, me, the instructor. Okay, so you don't get to choose that. However, for your own projects, you do. You're going to choose to put something under Git control and choose when to branch and things like that. So this tutorial aims at that use, outside of class, outside of work, for your own project. So what are we aiming for? What are you going to get out of this? Okay, you're going to learn how to put your projects under Git version control. You're going to use Git to help deal with typical problems like files get messed up and you want to return them back the way they were. You want to make sure Git can ignore things. And when should you create a new branch? So let's do this and get hands-on. So the first thing we're going to need is a project directory. Okay, to keep things. Whenever you do a project, especially web-related, software-related, you usually have multiple files in a project. And so we keep those organized in directory. We're going to start with a project directory, and that's how we're going to work with Git. So the first thing we're going to do here is somewhere on your system that's easy to locate, you're going to create a directory to hold your practice project. Create a directory to hold our practice project, and create a new text file in that directory and add some text to save. So let's look at what I got here. Okay, here I'm on a Windows machine. Macs and Linux will be similar. So here we're looking straight at my C drive. We see all sorts of stuff here. But what I did was I created a directory at the top level here on my C drive called Practice. Currently, there's nothing in it. Within this directory, I'm going to create a practice project folder. New folder. Okay, new folder. This is fun, so we'll call this fun stuff. We're going to do all our work in this folder. Let's go down into it. Okay, this folder is empty. Let's create a text file. New text document. I don't like spaces and file names, so let's do something simple like my first .text. Okay. Let's use some kind of editor to add some stuff in it. I'm going to use a real simple and lightweight editor for this demonstration. Okay. When I actually do lots of code work, I use a heavier weight editor, but Notepad++ or any editor is fine for this work. Okay, you need a text editor. So this is my first file in this directory. I'm making this directory my project directory. Okay. Save it. Use whatever keys you're familiar with. Okay, so we've got a text file. We've got a directory for our project. Okay. We put it in another directory. That's fine. Okay. Now we've got a text file in there. We've saved some text to that file. Next step. We need to bring up a command line terminal. Okay. Folks on Linux, folks on Macs, you got nice built-in stuff. Okay. For folks on Windows, what I recommend using is what comes when you install Git. Okay. There's something called Git bash. Why am I doing a command line thing here in the age of GUIs? Is the Git command line is the most powerful of the command lines. I mean, it's the most powerful of all the tools for working with Git. All the graphical user interface or GUI tools are actually based. They have a graphical front end, but they're just calling the same command line commands the same commands that you use from the command line. There's nothing that you can get from a GUI that you can't get from the command line. Usually, there's a lot of stuff you can't get to from a GUI. Okay. The other thing is, it's hard for me to teach 5 million different GUIs out there for working with Git. Okay. So we're going to use the Git command line. So let's see. We need to bring up a command terminal, set the terminal working directory to your project directory. Okay, for those on Linux, those on Macs, those using this nice Git terminal, we can use command print working directory to find out. Currently, we're at C users Greg B. Okay. While we're working over here in C practice fun stuff, we've got to get this terminal into C practice fun stuff. Okay, so we can go change D, C practice fun stuff. Okay, I use tab completion. Any good terminal will have tab completion because I don't remember how to spell all these things, and tab completion helps a lot. Okay, now we can see we're in C practice fun stuff. Okay. Set the terminal working directory to your project directory. Yeah, we've done that. Wait, put the project under Git version control. You're saying all we have to do is run git init at the command line now? So the hardest part was navigating our terminal to the directory. If I go git init, initialized empty Git repository in C practice fun stuff.git. What do they mean by that? Oh, look over here. This is where Git does all its magic. It keeps tons of stuff in this .git directory. If that .git directory isn't showing up, it's most likely because you don't have hidden items visible. Okay, this is the normal way you would see things. Okay, on Windows, just like if I go ls over here. On a Linux machine, you wouldn't see that .git directory. If I go ls -all, the directory is then visible. Okay, we can see it. So we come up here. Mac, there's something similar. Okay, so we want to make sure hidden items are checked, and we always want to make sure file name extensions are being shown because we're programmers and the extensions let us know what kind of files. So we put the project under control. We ran git at the command line. Oh, let's check our status. Git status. Git status. No commits yet. Untracked files. So Git sees that we have a file here and it hasn't been tracked. Okay. We can use git add to track. Let's see what we're going to do next. Okay, so in our workflow, we're going to create, modify, and or delete files in this project directory, known as our working directory. Okay? We then stage the changes, i.e. you choose which of the changes you want to get ready to commit. Okay? Then you do the commit. So it's this two-step process. Stage the changes, then you commit those changes. Okay? Some GUIs don't give you a two-step part. They don't allow you to stage the changes. They just do them all at once. So the workflow diagram is we start with the project, okay, in our working directory. We do various edits, adding files, deleting files, whatever, and we stage those to the staging area. Then we run the commit command, okay? To stage a file, use git add file. To make a commit, we're going to go use the command git commit -m my first commit, commit the stage changes. Okay, so let's try it. Git add, and what's my first command completion is always helpful. Okay, we did that. Now we'll go git status. Always type git status. Oh, instead of saying it's untracked, now it shows, up here it showed untracked in red here. Now it shows changes to be committed. Okay, we have a new file now. It knows that we want to commit it, that we're staging this new file that we created. We want to stage this, and now we're going to commit -m. -m for message. It allows us to include the message right here. My first commit. Dash. Command not found. What did I do wrong? What did I do wrong? Git commit, not commit. Git commit. Okay, it says master. My first commit gives us some funny looking stuff here. Now let's go get stats. Nothing commit to commit. Working tree clean. Okay, so we just did a commit. Okay, and the working tree is clean. So we did that initial commit. Let's add some directories and some more files. Okay, let's see how that works. Okay, and maybe learn a couple tricks. So we're going to make a subdirectory. How can we do that? Well, we can do it this way. Make a folder. What should we call it? Oceans, because I like oceans. Okay, we could do make a folder that way, or we could do things from the command line. Make dir seas, because I like oceans and seas. It doesn't matter how we do that. Now let's do a git status. Oh, let's make some more files too. Quick way to make an empty file without having to go through all that stuff is to use the Linux, Mac, Unix, whatever command, touch. If I'm going to say touch second.text, shows up over here. Touch my third.text. Now let's do a git status. Untracked files, my third, shows my third and second, but it's not showing the directories. Strange. Let's try adding a file, ocean, Pacific.text. Okay. Did we get anything in here? Oh, yes, here's Pacific. Edit with Notepad. I really like the Pacific Ocean. It's our closest ocean to California. Not necessarily interesting text. Now let's try doing git status again. Git status. Oh, now it's showing oceans. Strange little thing about git. Empty directories, it doesn't necessarily see because it doesn't know if you care about them or not. Okay, so let's go back up to fun stuff. Now we want to get things, we want to add things. Typing in add for each one of these new files is a little tedious. So we can just go, this is a command line thing, and if you're using a graphical user interface, you'll never need to remember this, but git add dot should have added everything for me. So let's check git status. Ooh, look. It sees and added the two new files. Okay, Oceans saw the file in here, but Seas had no file in it. Okay, that's fine. Let's do a git commit. Git commit. Wait a second, I was supposed to do -m. What is this thing? Oh, this is scary looking. This is some weird Unix, Linux, gobbledygook. How do I get out of it? Control C, Control C. Oh shoot, Control C is not working. Oh my God, panic, panic, panic. Okay, calm down. This is the VI editor. It's the default. It's weird. It's from old Linux, Unix, well, Unix days from the 80s or 70s. Just pay attention here. Type :QA exclamation mark. :QA exclamation mark. Gets this out. Commit was aborted, so nothing was committed. Go get status. Okay, but don't panic. Okay, I know that's a weird looking thing. If you really want to be able to put in complicated text messages commit messages from the command line, and you don't like that editor, you can do something like git config -- global core.edit, or don't think I remember this, I just looked it up. I would recommend you just say nano. This is a simple, easy to use little command line editor. If you're working with the command lines, your up and down arrow keys let you easily go through the command history. Okay. Oh, well, this is a little friendlier looking editor, and in particular, it tells you how to exit, how to write stuff out. Okay, and it starts us right in the place for writing. Can you see this up here? My second commit, it includes a couple new files and a directory with a file. Okay, and according to the instructions here, that up arrow means control, so I go Control O, and I don't change that name. Okay, then I'm going to go exiting to exit, Control X. Okay. Now, you will never need to use nano if you or VI or have that issue come up if you remember your -m. Or for the usual type of stuff where we're just adding and committing files or deleting and file changes, graphical user interfaces work great. Okay, so I will tell you that I use them. Okay. In fact, what you're seeing here is icons set up by Tortoise Git to show me what things have changed and haven't changed. Okay, this is an add-in that only works for Windows. There's other add-ins for other systems. Okay, so where are we now? We've got these changes committed, git status, nothing, working tree clean. So we added and we staged things. Let's check the project history. Okay, we're going to use git log for that. Okay, we'll see all the different commits that we've done to our project. Okay, and we're going to see a long, scary string of digits. Okay, don't freak out. That's the commit hash. That's really important. Okay, so we're going to use the command here, git log. What does it say? It says, oh, my second commit. It shows the latest commit first. Okay, so we've done 2 commits. My second commit includes a couple empty files in the directory, and my first commit. These numbers, these strings, uniquely identify each of these commits. Okay, which means I can uniquely I can use those. We're going to see how in a second. We checked our project history and we saw we have 2 commits. Okay. It turns out I can go back in time to take a look. We'll do something a little bit more elaborate when we want to go back in time and start working from an old place in time. We're going to do something slightly more, just tinge more elaborate. Okay, I'm going to go back in time any point using git checkout commit hash. You don't need to use the full 40 character hash though. Okay, let's go back to our first commit this way. Okay, you only need to use enough of those characters. Okay, so let's take a look. So we've got git log. Let's just take git checkout. We're going to give it a git that hash up here. That's 640A7. I'm going to try 640A7. Let's see what happens. Watch these screens. What did it do? You are in a detached head state. You can look around and make experimental changes. Okay. Wait a second. I went to the latest commit. I want to go back further. I want to go to this commit. I knew something was off. Okay, so let's go to the first commit. That's going to be, we're going to need a little more room here. Okay, so git checkout, and I should have given it 8CE private. Probably enough there. Ooh, well that's interesting. My second text file went away. That directory Oceans with its text file went away. Uh-oh, doesn't exist anymore. Keep this file in the editor? No, it doesn't exist. Wow. We lost our files by going back in. Wait, we didn't lose our files. We just went back in time to see the state of our work previously. How do we get it back? Good question. So when? Okay. What happened to the files from the second commit? They don't exist at the time of the first commit, so we actually went back in time. Okay. Run git status. What does it say about the head? Git status. Head detached, whatever that means. Nothing to commit, working tree is clean. Okay. What it means is that head status is we're sitting here in Git, but we're not pointing to where the latest changes were. To put that back, we're going to issue a command that will take us to the place where we left off. Git checkout, just like we did before, but instead of giving it a hash, we're going to say master. Master is actually the default branch. Okay. The files came back. Let's watch that slowly. Okay, we're going to go check out in the first commit. Files went away, right? Because that's from the time of the first commit. If we go git checkout master to bring it back up to where we left off, we see all our files come back. Okay, so we can go back to any point in our history, any commit we do, and look at our files. Okay, so if something was working in the past but no longer working, we can go see what that was. Okay. Now, let's try recovering from simple file deletion mistake. Okay. So, where are we? First, before we try anything here, git status. On branch master, nothing to commit, working tree clean. So, let's come over here and delete my first. Okay. Now I want to get it back. How do I get it back? Well, I can go to the recycle bin and all that stuff, but git will help us out here. So, type git status. Says, changes not staged for commit. Use git add remove file to update what will be committed, or git checkout file to discard the changes. So if I want to just recover from deleting this simple file, a simple file deletion, single file deletion, I'll go git checkout my first dot text. Oh, it's back. Okay. Git status. Ah, everything's back. Cool. Let's get violent. Let's get rid of those guys. Some kind of gremlin running around. Let's get rid of that directory there. Okay, then the gremlin says, I deleted your directory and stuff. But this only test. Now, Git's going to tell us what's changed. Git status. Oh my gosh, a whole bunch of files have been deleted. Okay. Git checkout, I could discard recover each file individually. A simpler way, though, is we're going to do a reversion. Okay. We've got multiple files and changes. Okay. Remove a couple files from your directory. Add or delete text from a remaining file. We're going to get everything back as it was at the time of the last commit. Okay. We're going to ignore all the changes that just happened. Okay, we're going to go git, and the way we're going to do that is we're going to do the command git reset --hard. Okay. And git --hard reset. And you can't remember the commands. Git reset --hard. Ooh, all the files are back. Okay. Git status. Everything's clean. Okay. So that's a good one to know in case of emergency. Okay. Things get confused. You were working hard on some problem and then things got wacky. Okay, changes happen to multiple files that you didn't intend and things like that, and you can't figure out what's up. You go back to the previous commit. Okay, so it's back to the previous commit. What's down in here? Oh, those changes weren't remembered. Okay, because we went back to the previous commit. Okay, this is why, unless you have other constraints, particularly when okay, I commit often. Okay, when you're doing homework problems for my class, when you're working on your own personal projects, commit as often as you like. It doesn't cost anything. These are just text files. Okay, the changes Git is very efficient at keeping all this stuff and the changes to all these things. Don't worry about that. Okay, how do we make Git ignore things? Okay, create a directory that we want Git to ignore and put some files in. Create some files of a specific type that you want Git to ignore. Okay, so we haven't been doing anything with C's here. So let's go, let's put a couple things in C's. C's, touch C's, what is it, black C? Dot info, touch C's, green C dot info. I don't think there is such a thing. Oops. Touch C green C dot info. Okay, do we get some files in there? Yes, we did. Okay, we got files in there. Okay, now let's create touch a couple random files. Dot temp. Touch dot temp. Okay. You'll get status. Git sees that we have put files in this directory that we had none in before, and it sees these two temp files. Okay. There's a lot of files we want to ignore when we work on programs. Okay. Things that we generate every time we change the programs, like object files or exes, or in websites when we generate distributions based on a bundler, etc., etc. So we want to be able to tell Git to ignore certain file types and certain entire directories. Okay, so how do we do that? We're going to make a file called .git. Notice the dot, git ignore. Okay, we're going to take this file, open it up with our little simple editor, and we're going to tell it to ignore things. What are we going to tell it to ignore? All files with temp as their last name, and we're going to tell it to ignore the entire contents of the C's directory. Okay. Let's see what git status tells us now. Git status, not just status. Oh, it's ignoring the temp files in the C's directory now, but it does see the git ignore file. So we're actually going to commit the git ignore file. So now we can just go git add everything. We can go git status to see what got added. Only one new file, none of those icky temp files that we created. Nothing in the C's directory. Okay. We'll go git commit -m adding .git ignore. Okay, if you don't, there's syntax that goes into this git ignore file. You can look it up. But what I do is, when I put things in here, I just check git status to make sure it's ignoring those things I want ignored. Okay. So I just edit my get ignore, check get status, if it's still showing up things, and I go figure out what my syntax needs to be, and that stuff's available. Okay, so we created a get ignore, we edited our get ignore. Okay. Branching. So we saw we could go back to any place in time, okay, in our project. However, we saw there was this weird detached head statey thingy, whatever. What we're going to do, really, when we want to go back in the previous point of time and start working on our project from there, we're going to create a branch, okay? It's just a new pointer to our current line, to a new line of work, okay? That's what we kind of mean by a branch. The other time I branch, okay, so we want to go back to a previous point of time in our project and start working from that point on, okay? Whatever you were doing didn't work out, and you want to go back to some previous time. The other thing is, when we kind of know ahead of time that we're going to try some major changes, either we're going to add some new feature that we're not quite sure about, or we're going to try to use a new library that we've never used before. We branch before we even get started with those changes because we know it's something that we may not want to keep. We're trying something out. Okay, instead of having to go back in time, we'll just create a branch, start working on that. Okay. So let's try this. Let's add and commit some stuff first. Okay. Create a file within the project directory called sunflower. Okay, and add some text to it. Also change some other files. Then add and commit those changes. Okay. So I'm gonna go. So get status is all clean. Okay, let's double check get status. Then we're gonna go touch sunflowers.txt. Okay, so we have a file, sunflower.txt. Okay, edit with Notepad. I like to grow really tall sunflowers, but the birds are enjoying eating them. Okay, so we added some text to that. Let's go back to my first one. Maybe I should protect my sunflowers from the birds. Save. Okay, so we added some text, we changed some things. Let's check what Git tells us. Git status. It says I've modified a file, I've added a new file. We'll go git add dot. We'll go git commit -m stuff about sunflowers. Okay. Let's see what our instructions tell us to do now. Okay, also change, add, and commit the changes. Okay. Let's say we don't want to include sunflowers in this project. We change our mind, we want to continue in the direction, okay, and we don't want to continue in the direction we started in the previous step. What we're going to do is go back and start a new development branch before the previous commit, or anywhere we'd like to live. The general form of how we do this is we go git branch name, and we give it the start point in terms of a hash. There's more, you could actually give it a start point in other ways than just a hash. Okay. Okay, so what do we need to do? Use the git log command to find the git hash from when we want to start. Use the get branch no sunflowers. Oh, we're going to name this no sunflowers and give it a hash thing. Then we're going to use get branch to list the available branches. Okay. We're going to do this all at the command line. We're going to go get status just to check. Okay, we're on branch master, nothing to commit, working pretty clean. Then we're going to go get log. Okay, so here's my first commit. Here's my second commit. Here's the commit about sunflowers. So let's go back to here. Okay. Okay. So we'll go. What did I say we were supposed to do? Get branch no sunflowers. I'll give it a hash. I think I did a copy thingy with this. Paste that hash. Okay. Well, did it do anything? Didn't change anything. Let's go see. Let's give it the get branch command. This is going to list all our different branches. We have two branches, master and sunflower. This little star here means we're on the branch, master branch. Okay. What do we need to do? Use get branch to list the available branches. Okay, switch to the branch you just created with get checkout sunflowers. No sunflowers. Okay, so let's watch this. Keep an eye on this files as we type get checkout no sunflowers. Whoops. It would be good if I could type. Check out no sunflowers. Oh. We see the sunflower file disappeared from our working directory because we went back to a point, okay, before, okay. Oh, my editor is going to tell me this file has been modified. Yes, I want to reload it because Git changed it back to where it was before sunflowers. Now, though, if I go get status, it tells us we're on branch sunflowers. No warnings about detached heads or anything like that. We're all ready to start work. Okay. Touch sad file.text. Why are we sad? Oops. Sunflowers make me happy. Yeah, that's why we're sad. But I like lots of other plants. Let's change another file. Let's go over to second, see what's going on with second. Too sad for me. I want more plants. Okay, let's see where get status tells us. Get status. It says, let's see, we modified a file, added a new file. Let's just do our usual get add. We'll stage them. And we'll get commit -m sad message no flowers. Okay, so where are we now? Get log. We've got sad message no flowers added. Wow. seems to be missing some of our history. Oh, it's only showing the history of the no flower branch. Ah. Now we can go back to having some sunflowers. How? Well, let's double check. Bit branch. There's two different branches. We put the sunflowers back on the master branch. Master is also the default name that Git gives to the very first branch. So it gave us that name. You can change it. You just look up, there's a command for changing the names of branches. You can change any of those names. Okay. To go over to that, we can go Git, checkout, master. When we do that, watch to see if sunflowers comes back and sad went away. In addition, this file is back to being empty. This file doesn't exist. Sunflowers is fine again, and my first text goes back to where it was. Okay? So this is how we can pick a point in time to go back and work on things and work forward from those changes. Now, the last thing is the case where I told you that we're thinking about doing some major changes. Things are working just fine and dandy. And I'm going to try something new. And I don't know if I want to keep it. I don't know if it's going to work out. Maybe it's an idea for a new feature. Maybe I'm going to try using a new component library if I'm doing something with React or Vue or whatever. Okay. So here, I'm going to start trying to raise cactus. Okay. So I'm going to create a branch called cactus ahead of time. Okay. I'm going to start from where I want. Okay. Where do I want to start my work from? Well, this is a good place. Right here. Git checkout mastered like we did. Now we're going to create a new branch from this place. I'm going to just go git branch cactus. We're not giving it any hash. Okay. Git branch cactus. Now if we go git branch, okay, we see that we created the branch cactus. Okay. However, we're not currently on branch cactus. Okay. We're on branch master. To get to branch cactus, which is the same as branch master for right now, we go git checkout cactus. Okay. And of course, we got to add some stuff. Touch a file thorny.txt. Okay. I also like cactus with a cacti. Let's talk about them. Okay. Touch thorny. Cactus are great. Okay, let's see where we are now. We're on git branch. We're on branch cactus. Okay, we'll get status. We got a couple of files. We got a modification, new file. We'll go git add dot all git commit m first cactus commit. Okay, now let's make some changes. We don't need that file third. Cactus are great, but can be dangerous. And yes, they can be. Let's check our changes. Git status. We deleted a file. We modified a file. Git add dot to stage all those changes. Git status to see what they are. Okay. Git commit -m second commit to cactus branch. Now, how many branches do we have? Git branch. We've got 3 branches. We can switch back and forth as much as we like. These extra branches, they don't take up any extra space or anything. Okay? Very little extra space, I should say. That's trying to be accurate. Okay? It's okay to leave them hanging around. Okay? Even if you're not doing anything with them. Okay? We'll be doing that with the homeworks in my class. Okay? If we go git log, we see the history of a branch. Now, this is one place where graphical user interfaces are helpful. Okay, and so I'm just going to show you one, and mostly because it allows us to see our branch history. I don't use this one myself, but I want to visualize all our branch history. So here we go. So we can see from our first commit, our second commit, adding git molar. This is when we went back in time and started the no sunflower branch. We can see there was only one commit on that branch. Then we can see we did more stuff. We have our sunflower work. We branched off cactus. Okay, and it's interesting. You can see that each branch is shown in this visualizer like a little tag pointing to the history, and the history goes backwards. Okay, this is our history tree. Okay, we can go to any place in the history. Nothing is lost. Okay, you can even see our friends down here will show us that full hashy thing if we need it. Okay, very powerful. Okay, there's yet more things you can do with Git. However, trying new things and being able to safely try new things on your project, being able to go back in time, being able to recover things. Didn't use any remotes, didn't use GitHub. This is just using GitHub locally for our personal projects. Okay, very useful. Okay, once I have some code that I want to keep around a little bit, I put it under version control. Okay, why? Because it's so darn easy to do. Okay, we saw it. Just get init in the project directory. The entire history of the project is kept in this .git thing in an organized fashion. We never mess with this. Okay, if you don't delete this file, you are pretty much safe and can recover any of your previous work. If you delete this, you're out of luck. Okay, it's a good habit to get used to, and you saw we didn't need too many commands. Going further, you might actually pull together branches and do something called a merge, even on a personal project. It's something that you wouldn't have to do very often, so you read up on it as you go along. But we saw branching is quite simple, easy to do, okay, and moving between branches isn't too difficult. Okay, so I really, really recommend you get hands-on, outside of work, outside of class, with a project, or at least a test project like this, where you mess with Git to see its capabilities for going back in time, creating branches and doing stuff without worrying about messing with your work repos or your class repos and things like that. Okay, we'll talk to you all later on the next tutorial. Bye-bye.